to answer some of your questions, okay, after class. So you can stay after class so we can talk if you have any question. Anything specific you would like to speak, we can talk about it after class together, okay? So let me just do one last thing that don't show up in my computer. I need the chat to be open just in case somebody chats something. Okay. This is what happened. Right now, we're going to be talking about organizing categorical data. So in the previous section, and probably the one that you read, it gave you a definition of statistics, and it also give you a definition of data, what they are, and also categorical data, and so many other stuff. In this section, we'll be talking about organizing categorical data. Okay, so give me one moment. Just put that person in. So I have to do it that way. That'll be easy. Let's put it one down right here. Okay. So this one, the first thing I show you here is something called a two-way table. Okay. We have a two-way table, like you got like 4 elements. We got one column for men or column for women. Okay, so it's 2 things: either you men or woman, and the other one will be always and not always. This type of data thing is called a two-way data. I'm sorry, two-way tables. Okay, as you can see, also it shows how many times each combination of the category occur. For example, this one say best practices. Okay, so how many men say that do not always do it so? As you can see, 2 men say they don't always do so. And then how many men say, or how many women say they do it all the time? As you can see here, 7 women will say they do that all the time. Let me just mark it for you. So here, 2 men say they do it all the time, and not sometime, not always. And 7 women say they do it all the time. Okay. So the practice, the seatbelt practice, it depends all the time. Okay. So so that's what I just say. And just keep that. So one thing I can know about that table that is also very important. It can also give you the number of everything. Like for example, how many men do we have? We can say if you add these 2, you got 6 men in total and about 10 women in total. That means they survey about 16 people. Okay, and the one on top it will just confirm what I just say. How many of them say they do not always practice seatbelt? So the first one will be 5, and the other one will be 11. If you add this number also, you give you 16. That's one thing about the two-way tables as well. Any questions so far? That's just a table. There's no real definition here. Okay, so we expect to see something like that all the time. Okay. Okay, so I just told you earlier, if I ask this question, how many women were surveyed? What will you guys say? You can just type in the chat. I just give it to you, the answer, but just on the side. How many women were surveyed? Okay, 10, perfect. So we got 10 women were surveyed. Okay, so let's just show the answer again. So you do 3 plus 3 plus 7 is equal to 10. Now they show how many from the survey always wear a seatbelt? How many from the survey always wear a seatbelt? Thank you. That's 11. Thank you very much. And then the last question would be, how many women from the survey do not always wear a seatbelt? That would be 3. Thank you. So that's what we call a two-way table. Okay. Okay, so the numbers are called the frequencies. Okay, and the men and the woman, women, not always and always, it's just like variables, but that's all it's about this table. Okay, so we're gonna do some more stuff on it. So what we need to do now is to enter something called percentage, right? Remember that we have a total of 16 people. Okay, so let's do that. Let me just draw right here. So we have a total of 16 people. This is going to be like 11, 5, that will be 10, and that'll be 6. This is the first question I asked you. What percent of these people are men? What will you do if I say what percent of these people are men? So remember that how many men we have in total? We have 6 men in total. Okay, we have not. I'm sorry. Yeah, how many? We have 6 men in total. How many people were surveyed? How many people were surveyed? We know that 16 people were surveyed. Okay, 16 people were surveyed. If you do that in your calculator, I'm not able to access calculator right now. Can somebody give me that number? 6 divided by 16. Well, I can just make it simplified first. That would be 3/8. Okay. That'll be 0.375. Thank you very much. So here, as you can see, I expressed the answer into 2 things. One is a fraction, and the other one is a percent. This is a decimal. Okay, but because I want a percentage, let me just do that quickly. Because I want percentage, what I can do, I can change this one into 37.5%. Okay, so this is the percentage I was looking for. Okay, so we like to express the number. This is percentage. Okay, this is percentage. So they say, well, I mean, what percent? I mean, you're gonna say about 37.5% are a survey. You can also say 0.375 as well, 0.375. Okay, that's fine too. But for now, because it's a percentage, we're gonna say 37.5%. Okay, or can just say 37.5. All right, so this is what we just did. We just did that. There's a small mistake here. I didn't fix it. So this should give you not that. This is not the answer. This is because I said I'm 100%. I need to say 37.5. Okay, because I multiply by 100%. Okay, right? You can say 37.5. All right. Questions about that? Okay, no questions. So this one say what percent what percent always wear a seat belt? What person always wear a seat belt? So we'll do the same math. How many people wear seat belt? So we don't know what percent of them wear seat belt. Thank you. So somebody already did it. And as you can see, 11 people wear seat belt out of 16 people in total. Okay. So that's gonna this time the 100%. I put 10% by mistake. That's gonna give you 68.75. 68.75. Okay, this is not correct. So this is the right answer. You have to put 68.75. If you don't show the time 100%, you have to put 68.75%. So we know what we do. In fact, you need to put it anyway because the percent is in the back of it. So you're gonna have to put the percentage right here. Okay. So that'll be 68.75%. All right. So let's keep walking. So I know that you guys have no question, but we're gonna talk about a couple of your stuff that we can understand. So let's see what we do here. This is an example that we have here, just to get you off the idea of the men and women thing. This one say, of 400 students who were surveyed, 65% of them were carrying their calculators. Of those carrying the calculators, 40% were men. This thing tried to drive you crazy because they out of the 400 students who were surveyed, 65% were carrying their calculator. Okay, and out of those who were carrying their calculators, 40% of them were men. So this is something I want to point out to you. Whenever you see the word of, it means multiplication all the time. So they say of 400 students, 65% were carrying calculators. So if I would like to know how many people carry the calculators, so what I'll do, I will say 400 times 0.65. Okay, oops, sorry. That's what happened. This one always happened to me when I'm using PowerPoint. Always messed up that thing. So 400 times 0.65. This will give you the number of people who have the calculators. So remember, whenever you see the of, it means that multiplication. So try to remember that. The of this number, this other, that then do multiplication. Okay, so you're gonna do 400 times 0.65, and that's just gonna give you a number. And then how many people you can say carry the calculators? So you're gonna do 0.65 times 400. How much is give you using the calculator? So that's gonna give you 260. Thank you very much. So now this one is saying, of those who carry their calculators, that's of the 260 who carry their calculators, 40% were men. Okay, so that'll be the question we're gonna ask. So we want to know the following question. So we just did the first part. We say, so how many of these people were carrying the calculator? We just did 400 times 0.65, give it to 60. Now this is the next question. How many female students were carrying a calculator? How do you see this one? This one says, how many female students were carrying a calculator? If we want to think a little bit. How many students? How many female students? About 40% were men of them, of the 260. So this one says, how many female students were carrying a calculator? Thank you very much. Because they say 40% were men, so I'm assuming that 60% will be female. Okay, because 50%, 40%, 60% plus 50% plus 40% give you 100%, which is a whole. Okay, for us 100% will be like the perfect thing. So what we're gonna be doing is gonna do 260. Or let me just write it down instead. Let me just let it go by itself. Oh, by mistake. So let's do that instead. Let me just erase that so you can see what I put. So you're gonna say 260 times 0.60, that'll give you 150. Okay. There are more examples I would like to go over with you, but I'm just gonna skip a few because the idea is kind of the same thing. Then I'll come back to it after that. Okay, I'm gonna skip the next example, but we're gonna just try to write a problem together. Okay, so let's see. I'll go back to this example if I have time. Like this one, I'm gonna come back to it after that. So let me just do this right here. And we're gonna come back to the example, okay? This one quickly. This one say, that's one part also. What we just did, I'll just talk to you about something called, earlier today, something called a two-way table, okay? I have more example for the two-way table. I'm just gonna go over it soon with you. I just explained to you, we can just use it to do percentage, to do a decimal, define this percentage of something. As you can see, whenever you do percentage, like earlier today, we saw that 0.75, something like 375 people were female, something like that. You can say about 37% are female. Okay, we understand the idea of a percentage very easily. So what I want to do now is to make sure that we got a couple stuff that is very important. Let me see, where can I go? I know before I go just to this one. So let me use that before. Let me go down 2 slides first, right here. So let's do this one first. There are some missing statement. Let me see. So this is something that you need to understand. So whenever you use, these are something that you understand. So use a two-way table to display result of 2-question survey or 2-outcome experiment. Okay. Use percent or rate rather than counts when comparing group with different size. These are 2 things we try to remember. Okay. But I'm not going to ask a question about this later, but just for you to remember to understand the weightables. And also, there was an example about China thing, but let me see if I can go over it quickly. No, I don't want to talk about that one now. I'm going to be talking about it soon, okay? As you can see, this one say, China's total CO2 emissions are higher than America's. So the Chinese are worse polluters. So I'll come back to this example soon. So let me just go over that one first. Okay, right here. So what we're going to be doing, we're going to understand the idea of causality, collecting data to understand causality. So let's talk about that quickly. The first thing we want to understand something called establishing causality. Establishing causality means to show that an outcome is affected by some treatment. We're going to be talking about that, okay? So I know it's just making sense, but we're going to be talking about that. A treatment group, that's important. A treatment group are the individual will receive a treatment. Okay, so we need to remember that a treatment group, let me just get my pen. A treatment group are the people who are receiving the treatment. And on the other side, there's something called a control group. A control group are the individual who do not receive a treatment. Okay, so they do not receive the treatment. Okay, so that's very important. For example, to see if red wine decrease the chance of heart disease, if we're gonna give 800 red wines drinkers, I'm gonna take 800 red wine drinkers and 900 non-red wine drinkers. You're gonna observe both of them. So these 800 people will get the real red wine, okay, and 900 will get the non-red wine. Okay, it's hard to say the word at the same time. So you're going to compare the 800 and the 900. Okay, that's where you can get an idea how to get an idea of to understand the causality about the heart disease. Okay, so in that case, the 800 will be considered as a treatment group because they are the one receiving the actual treatment. They are the treatment group. while the control group will be the 900 people. Okay. Any question about that? Oh, somebody has a question. I'm listening. Or did I skip your question? Christopher, you have a question? I don't hear anything. Can you guys hear me? Can you guys hear me? Can you hear me, guys? Can you hear me?
Yes, we can hear you.
Yeah, somebody has a question. I was going to make sure that, okay, so, okay. I thought, Christopher, you had a question for me? You said I had a question, so I don't know if I skip your question.
All right,
He put it in the chat.
Okay, I'm listening.
I was just asking, what are the real world applications for like this lesson?
Oh, that's just the introduction. It's like you I'm just laying the ground. It's like I'm just giving the basic ideas, like vocabularies, to understand what we're gonna be doing.
Okay, I understand. Thank you.
You're welcome. Okay. I mean, the introduction is always like gonna be really, really wide because I have to introduce the idea to you. So that's what happened. And after that, we're gonna be talking about so much numbers. Okay. So let's keep walking. We're gonna be do the application to them soon, okay? But soon, okay? So you have to understand something. So when an anecdote is a story that a single individual tell about his own experience. So somebody experienced something, it's called an anecdote, okay? We don't want to apply an anecdote to everybody because it's a single person who experienced a specific experiment, okay? So an anecdote should never be used to make a statement about a group of individual. Okay, if you have an specific experiment, you don't want to say everybody does it because you decide to do it. Okay, that's why I say, for example, if Jack drank peanut juice and noticed that he became much healthier, that doesn't mean that peanut juice make people healthy. Okay, that's his specific story. Jack drank peanut juice. He feel like he's healthy. Whenever you drink peanut juice, it doesn't mean that it's gonna be the same for everybody. So that's what they call an anecdote. Okay, so make sure you understand this idea. So as statisticians, we're gonna make sure that when people say stuff, we don't take them for truth, because that's their own experiment. Okay, so that is very important, that idea of anecdote, because right now people have access to media and can get their idea to everybody. And say, for example, I drink this specific juice, and what happened, I become like my brain become extremely super smart. Then you should get it too. So that's one person having a specific experiment with that specific drink. You understand? But it shouldn't be applied to everybody else. That's what we call an anecdote. So there's something also in statistics, something called observational studies. So we're gonna conduct an experiment. Whenever I do the experiment, we're gonna try to make everybody into two groups. Okay, we're gonna compare these two groups. One of them, this is what we're gonna call a control group. Whenever the control group, okay, I don't have to spell group, but I'm just gonna put it. The control group, and the other one will be, I don't know if you guys remember what I just said about the other one. Remember the name of the other one?
Treatment group?
The treatment group, thank you. So this one will be the treatment group. This one, let's see. This one be receiving, the treatment group will be receiving the real thing. Like the other one can be given a placebo or something like that. And then you're gonna do the experiment. Okay, and then you're gonna try to see the difference between both of them. From the difference, we're gonna make a conclusion after probably a few days, 30 days, or 100 days, whatever it is. Okay, so the same thing also, you're gonna also on observational study. So use groups that are already created and we call the difference. So this one gonna use some of the group that are already created and we call the difference. Here, what you need to do now is just know the definition, okay? So on the exam, they say, what is an experiment? You can say two group and we call the difference. What is an observational study? You're gonna say, look for something that are already created and then you will call the difference. So when each one of them we call the difference. That's something that is very important. We call the difference, okay? So, so let's see again. So this one say if an outcome occur more often with one of the group than the other group, we say that the treatment and outcome are associated, okay? We can say that there's an association. If something happened more to one than the other, you see they are associated. So these are terms, again, you need to try to remember when taking the exam. The code 10 is that you are allowed to use the notes in the exam, okay? So take notes whenever we go home. I know what I'm saying, we're not in class, we're in Zoom. Whenever we finish or whenever you're studying, take notes, okay? And then of what we did in class, I will upload, I will let you see the video after class probably. No, not necessarily. But I'm gonna put the notes, the book notes for you. I'm gonna look at the notes in the book and then look at this other thing, write them down, and then get ready for your exam. Because it's like these are the terms you're gonna be saying in the exam. You understand? So you don't need to try to memorize everything. One thing you understand also, this one says association is not causality. Okay, so unless the individual of the study are identical in every way, except for the treatment, we cannot conclude that the treatment caused the outcome. Okay, sometimes they might be just an association. It doesn't mean that the one caused the other one. Okay, sometimes might be just a correlation between both of them, but the one doesn't cause the other one. Okay, so that's something also you need to understand about association. For example, somebody with gray hair is observed to have more wrinkles, okay? This doesn't mean that because you have gray hair, that causes wrinkles, okay? Having gray hair doesn't really cause wrinkles, okay? We know that as we age, we get wrinkles and we get gray hair, but it doesn't mean that gray hair causes wrinkles. I remember when I was 14, my hair used to be just black and white, purely black and white, okay? So I was 14, people used to tease me at school, but I used to be cool with it. Whenever they asked me, what's your age? I mean, the white hair back, or the gray hair back, but having gray hair doesn't cause you to have wrinkles, okay? So they may have an association, but one doesn't cause the other one. Okay, and then another important terms you're gonna see that more very often, something like confounding variable, okay? So it's a characteristic other than the treatment that cause both outcomes. For example, old age causes both gray hair and wrinkles. So this is a definition that you need to understand, okay? So that's something that causes, we see that? It say is a characteristic other than the treatment that cause both outcomes. You being old will cause you to have gray hair and wrinkles. This is called what they call a confounding variable. That's something that put both of them together. So being old will cause both of you, because either it will cause you having gray hair, also it cause having wrinkles. Okay, there are some exceptions. I know people who are very old, the hair is still not gray. I mean, the hair is still not gray. But I heard also some people, whenever they get older, just also they paint the hair, they paint it so they can they can still look young. Okay, so that's thing we need to understand. Okay, so let me see. Let me keep working on that. So these are definitions you need to try to understand. You're gonna find ideas say confounding variables. That's again definition that you need to understand. Okay, so this is one is called a control experiment. So a control experiment, this again definition that we need to understand, is an experiment where each individual is assigned to either a control group or to a treatment group. Okay, is either assigned to a control group or either a treatment group. This is why I call a control experiment. All right. Don't confuse control experiment with control group. All right, this is not the same thing. Control experiment is an experiment where each individual is assigned to either the control group or the treatment. That's the way it is. You just have to try to remember it that way. Whenever you have your little notes, just write it down. Okay. So a few examples here. Okay, no, that's an example. That's a sample size should be large enough to account for other variability. Okay. Whenever you do a study, this one is very important. We're gonna talk about sample size very, very often in this class because that's very important. You don't want to do a study and just survey only one person, okay? Or you don't want to do a study and just survey just your friend and family, okay? And also you don't want to, the sample size, whenever you do a sample, it has to be large enough. So if it's large enough, you can make inferences. If it's not large enough, you cannot make any inference. Okay. So that's why we say whenever you do a study, make sure it's done randomly. Any person should be able to, not just your family, not just your friends, or not only one person. It has to be any type of person, and also a large enough. It doesn't have to be 100. It should be large enough. So in the future, I will teach you, I will talk to you about a number that you can use to figure out whether it's fine or not, okay? But not now. Why now just doing an introduction of the class. Placebos, many of you know what you call a placebo, okay? You get the fake pill or the sugar pill, something like that, okay? So let's read it. It said the placebo effect is a phenomenon of reacting after being told of receiving a treatment if there were no actual treatment given. That's mean what they give you, they say, oh, listen, I'm gonna give you that pill. If you drink it for 30 days, I guarantee you're gonna lose weight. The person doesn't have to use a sugar pill, but once the person believes that is gonna happen, in fact, most of the time, the persons are improving and start losing weight for real, not knowing that they were taking a fake pill or a sugar pill. Okay, let me see. This one say after being told by a doctor that an empty capsule will treat the treatment fever, the patient's temperature decrease. That's one idea. Okay, the person is given a fake pill, then the doctor say, just take it, you're gonna be fine. You're not gonna have a fever anymore. Once the patient took it, then it's fine. Okay, so that's called placebo effect. All right. So this is also very important, blind and double blind. Whenever you do blind study, usually it's supposed to, I want to do a study about some specific medication. I'm probably going to be the only one know about it. And when I give it to the doctor, I don't want the doctor to know that's a fake medication, because if he knows, then that can be a problem. Okay, so I want to be decided to be blind. Or the people who are going to take the pills, they don't know they're taking fake medication. okay? Because if they do know, that will validate the study. So that's why we call a blind study. That's mean that the blind study, the people who are taking the medication don't know which one they're taking, okay? But only I will know it. So a blind study is a control study where the participants do not know what they're taking, okay? The person don't know anything. While a double-blind study, where the person administering the treatment also does not know. That's mean here we're gonna have the person administering, this one will be the doctor. Here this is the doctor. Here, that's the person giving the pill, and the people do not know. Only I, who's the owner of the probably the pill, know the study. This is called a double blind. Okay. When I do if I do research, I like to use double blind, but blind study is fine too. Okay. So make sure that if you do one study, the doctor doesn't know, because you might change the study a little bit, because you're not really trust everybody 100% whenever you do study. And then you never know, the person can come and feel sorry for that person, and then give him the real pill. You want him to give either the fake pill or the real pill without noticing it. Okay, that's very important. So here, this is an example. So I'll give you a bunch of examples, but with this one, I can just read it for you. This one say a researcher wants to determine whether the researcher will be the statistician, wants to determine whether a multivitamin pill shortens recovery time from the common cold. Okay. So the researcher prepared 300 bottles of the multivitamin and 200 bottles of identical looking placebo pills. So that's mean got 200 of each. What he can do 300 of them will be like blue pills, the other one will be like red pills. Just like you have Tylenol, sometimes it can be different colors, sometimes it might be of placebo, okay? So, and then the bottle are marked with serial numbers that only the researcher can decipher. Only the researcher know how to distinguish it. Not even the doctor, the pharmacy doesn't know anything, or even neither the clinic doesn't know anything, okay? So I'm the only who's gonna know about that. Okay, say the pharmacist does not know which are which, but write down the numbers in a log. As I tell you, if I do the study and people start dying, I'm gonna get sued, okay? So know that as well. So that's why I started doing the research first at home, then make sure it's fine before giving to everybody. So let's see. Also, this item that you're gonna try to understand. So this one say use a computer or the physical method that when we divide the population into random things. So, I mean, things that we can do on this side, okay? An important term, you can use a computer, can do this by itself. You just say, okay, I'm gonna divide it if you want to. An important term that's also, this is a very important term. I'm gonna find my cursor. Where's my cursor? My cursor just disappeared. Okay, so this one is called bias. Okay, that's a very important term. It may occur when the assignments are not random and the results are influenced by in a particular direction. Suppose I ask you to make a study, you go and only ask your friends and family. For example, I say which political party you like the most. So if you just go and ask your friend, only it might not be a good study, because you see your friends want to be, try to please you. So the study might not be good. Something is influencing the study. Also, if you're doing a study and then you tell the doctor which one are fake medication, which one are real medication, of course, the doctor will never give the fake medication to anybody, because he knows that it's not going to do anything to it. So you have to make sure it's double blind. Okay. So this is an example, probably that's another example you probably can read in the future. It's a given tutoring to the first 15 register for 30 student class to see if the tutoring help with an exam score. This is bias, since early registrants are likely to be better students. So that's something you can read. So you get, if before an exam, for example, before an exam, I give you a tutoring, I help you out, then of course your grade is going to be increased, something like that. Okay, so that's bias. All right. That's a lot of talking. So I'm gonna skip the skip study, but what I want to do now is to go back to one of the very important example, an activity we're going to do together. Let's just go back here. So where was I? So this example here. So this is also part of the of what you call again of the two-way tables. So this one say this is an activity we're going to be doing together. So be ready. That's a small activity to do together right now. So let's see, let's look at it together. This one say, which cell will be most or least likely to meet? I mean, which state will you be? Will you be most or least likely to meet at least one person out of 50 random wisdom with AIDS? Okay, somebody with HIV, something like that. So out of 50 people are gonna meet on the street, at least one of them will have HIV, something like that, or AIDS. Okay. So here we have the numbers. They say that in New York, 75,252 people have AIDS. And then California is 65 something, and etc. Okay, and DC is 8,895. So therefore, based on that study, New York is ranked at number 1, and DC is ranked at number 6. Okay, so if you look at this rank only, you're gonna say, okay, New York is the right one because it got more people with AIDS. And DC is the right one because it got the least people with AIDS, because they say which one would be the most or the least. The most will be New York and the least will be DC. This can be deceiving. You don't just look at the numbers and assume that you can just make conclusion about them like that. Sometimes you have to do a little bit of work. Okay. First of all, let's see how many people are in each of these states. Okay. Assuming that there is a population of 19,297,729 people in New York, state of New York, and 75,250 have AIDS. So let's try to fill out this table. This is what happened. This one say population per thousands here. Population per 1,000, AIDS per 1,000 of population, and then you're gonna have a new rank for them after that. That's gonna be our work right now. So to get the population per 1,000, what I'll do, I'll take the first one, I will take 19,297,000 and then 729. I'll divide this one by 10,000. So you divide by 10,000, this is just going to give you 19, okay? 297, and then 0.729, okay? So because that 0.7 is bigger than 5, so you can wind it up to give you 19,298, okay? You guys with me? I'm sorry, 1,000. I put 10,000. It's 1,000. Why I do 1,000 and I put 10,000 by mistake. So here, let me erase that. It's 1,000. Sorry, 1,000, not 10,000. Okay. Any question about that? Any question about that? Or you got sleeping already? Okay, no question. Again, this is statistics. It's very boring sometimes. You have to have coffee with you to stay awake. That's gonna be the most boring class. But we're gonna try to make it interesting. And I'm not that interesting, but we can try. Okay, so this one give it that number, and the next number here that you see is you divide this one by 1,000 or so. Then this one goes away because we want to have the whole number. Then we do the same thing here, divided by 1,000. This one goes away. That's going to give you 18,251 per 1,000. This one will be 23,904 because the number now the next one will be 12,433 because the number before the 2 is bigger, after the 2 is bigger than 5. And the next one will be 5,000 divided by 1,000. So that's going to be 588. Okay. Any question about the numbers where I did them? Okay. So if there's no question, this is what we'll do now. So then this one is the heads per 1,000 population. Okay. So the heads per that, I mean, I have other way to that problem, but this is the way the book is trying me to do it. But just in case you have that specific problem in the homework, this is how you need to do it. Okay. So now they need to find the heads per population, per 1,000 population. This is what you do. You're gonna say the heads is about, for New York, heads is about 75,253. This one will be divided by 19,298. If you do the math for that, that's going to give you 3.9. So we'll do the same thing for the others. You're going to do 36,000. You're going to do 65,582 divided by 36 something. You're going to say 65,582 divided by 36,553. Okay. And then if you can do the math for that. Okay, and you do that for every one of them. So when I did every one of them, this is what I got. I got 80. No, I'm sorry, okay, I did it again. So I got for the heads per 1,000 population, I got 3.90 for the first one, 180, 2.63, 160, 146, 155, and 15 something. But notice something. Earlier, they just the rank were given to you as the number of heads, the number of people who have HIV, something like that. It's the number of people with the sickness. So New York got more people, and then DC got less people. But you need to take into account the population as well, because you want to know whenever you go on the street, if you meet 50 people at random, how many of them is the number of people will be who will be HIV positive, something like that. So let's see. Based on the data that we did study right now, as you can see here, the number one of them is DC. DC is number one because it got the highest AIDS per 1,000 population. And then if you do the math, you can see that number two will be New York. Number three will be Florida because they come after. Number four will be California. Number five will be Pennsylvania. And number six will be Texas. So to get the most people with AIDS, you're gonna go with AIDS. Let's see why is it? I'll just make it say again. get the most people, that will be the most. Because DC got a smaller population. And the least one will be Texas. Because Texas has a broader population. Okay. So if you go to Texas, each time you see 50 people, it might not be, that'll be the least people who have HIV. That's more people won't have it. But if you go to distant, that's what the studies say. Okay, so it doesn't have to be 100% true, but that's what our studies say. Okay, so we don't want to go with the first idea that because 75,000 people have AIDS, then therefore it's New York. Because 8,000 people have AIDS in DC, therefore DC will be having the least people. So you don't want to have the idea that way, because the goal is that if you go outside and you ask 50 people at random if they have AIDS or not, then the most place you're going to be seeing that based on the study, that will be in DC. The least place you're going to have people with AIDS, that will be California. Texas, based on the study. Okay. Any question about that? I got somebody waiting
No.
in the witness. Okay. So let me check the time. For some reason, I'm not able to see the time here. I should be able to see the time here. I don't see it here. So I'm gonna let you guys leave a little bit early today because that's all I had for you. So in that case, what I will do, I'm gonna put chapter 1 from the book for you available online for you to read. And then just because the first class, usually I don't give any of my notes. I don't put, no. I do give you the notes. I'm gonna upload these notes for you as well, okay? But not the video. Video is gonna be if I need to, okay? I'm gonna upload these notes for you. I'm gonna create a folder to upload this note for you. I'm gonna make it available for you. And then also the note from the book, so you can compare them, all right? Not the video. Video I put is if I need to, all right? But just these notes, I'm gonna upload them for you. Now, if you have no questions, so have a great night. Please do stay. I'll be seeing another 15 minutes. If anybody wanna speak to me one-on-one, and anyone have to discuss about. So now class is over. Let me just stop the recording.